Hello students, welcome to class 12 physics. In this video we are going to solve a textual illustration of chapter number 8 electromagnetic waves. So illustration number 4, light with an energy flux of 18 watt per centimeter square falls on a non-reflecting surface at normal incidence. If the surface has an area of 20 centimeter square, find the average force exerted on the surface during a 30-minute time span. So here the light falls on the square of area 20 centimeter square and we need to find the force exerted on this surface in time 30 minutes. So what is given is the energy flux, which is 18 watt per centimeter square. Area is given, that is 20 centimeter square, and time span is given, that is 30 minutes. So here we need to find the force. So first of all we will see the formula for the force. Here, if momentum gained perpendicularly by given surface is P in time t, then force exerted perpendicularly to the surface will be F is equals to P by T. So we are having one equation as F equals to P by T. Now for given perfectly non-reflecting surface or completely absorbing surface, P equals to U by C. That is, the momentum is over here is U upon C. And so now the equation 1 can be rewritten as, instead of P we can write U by C. So it becomes F equals to U by C into T. So F equals to U by C T. Now energy flux is given. Energy flux, that is the intensity of the given radiation. Let intensity of the given radiation is what? Intensity of the given radiation is energy per unit area per unit time. We know this equation. Intensity is energy, that is U, per unit area, that is A, per unit time, that is T. So U upon A into T. From these equation, let us take U as the subject and taking AT on the other side. What we get is U equals to IAT. Now use this equation in second equation. So that will be IAT upon CT. So TT gets cancelled and what we have is IA upon C. So we have this equation F equals to IAC. Now see, intensity or the energy flux, that is given 18 into 10 raised to 4 watt per meter square. Area is given, that is 20 into 10 raised to minus 4 meter square upon C, that is 3 into 10 raised to 8 meter per second. So when we calculate this, we get 1.2 into 10 raised to minus 6 Newton. Now as per the question asked lastly in the statement, if given surface is perfect reflector, that is incident energy is not absorbed at all, then momentum gained perpendicularly by the surface will be P dash equals to 2U by C. And so F equals to 2F. And it will be 2.4 into 10 raised to minus 6 Newton. So students, you may note down this numerical. Now illustration number 5. Calculate the electric and magnetic fields produced by the radiation coming from a 100 watt bulb at a distance of 3 meter. Assume that the efficiency of the bulb is 2.5% and it is a point source. So here the source of radiation is the bulb and the power is 100 watt. The distance from that is 3 meter. That is the we need to find over here electric and the magnetic fields produced by that. and also the efficiency of the bulb is given, that is 2.5%. So here efficiency of the given bulb is 2.5%. Hence the power of radiation emitted from it will be 2.5% of the whole. So 2.5% of the electrical power, that is 2.5 by 100 into 100, that will be here 100 watt that is given. So 2.5 by 100 into power, that is 100. So power will be 2.5 watt, that is the power for the wave that is radiated out, that is 2.5 watt. Now intensity of the radiation, we know intensity of the radiation, that is what, I equals to P by A. We get this equation by intensity is energy per unit area per unit time, and we know energy per unit time, that is nothing but power. So instead of that we can write P, so P by A. So intensity of the radiation is I equals to P by A, and here the area of that is for the bulb, we can write 4 pi r square. So P upon 4 pi r square. R here is the radius, that is considered as the distance from the bulb. So I equals to 2.5 upon 4 into 3.14 into 3 square. So when we calculate this, we get 0.02212 watt per meter square. Now according to the formula, I equals to epsilon 0 E RMS square C. So from this equation we can write E RMS square equals to I upon epsilon 0 C. Taking root on both the sides, we get E RMS equals to root I upon epsilon 0 C. So now we substitute the values of intensity, permittivity of free space, and the speed of the light, that is 0.02212 upon 8.85 into 10 raised to minus 12 into 3 into 10 raised to 8. When we calculate this, we get the value as 2.8864 volt per meter. So ERMS equals to 2.8864 volt per meter. In the same way, to find the magnetic field, we have equation I equals to Vrms square C upon mu 0. Taking Vrms square as subject, which is equals to I mu 0 by C. Taking a root on both these sides, we get Vrms equals to under root I mu 0 by C. Now substituting the values of I, that is intensity, permeability of free space, and the speed of light, that is C. So under root of 0.02212 into mu 0 is 4 pi into 10 raised to minus 7. So that is 4 into 3.14 into 10 raised to minus 7 upon 3 into 10 raised to 8. When we calculate this, we get the value 96.23 into 10 raised to minus 10 Tesla. Shifting the point, we get 9.623 into 10 raised to minus 9 Tesla. Now here the amplitudes of the oscillation of electric field and magnetic field can be found out as follows. Now see, we got the value of ERMS and BRMS. So from that we can get the amplitude of electric field and magnetic field. ERMS is equal to E0 by root 2. So take E0 as subject. So E0 is equals to root 2 ERMS. Now put the values of ERMS. We get 1.414 into 2.8864. And value we get is 4.0814 volt per meter. So amplitude of the electric field is 4.0814 volt per meter. In the same way, BRMS is equals to B0 by root 2. So B0 equals to under root 2 BRMS. Now substitute the values of BRMS. So we get 1.414 into 9.623 into 10 raised to minus 9. When we calculate this, we get the value as 1.361 into 10 raised to minus 8 Tesla. Thus, the amplitude of the magnetic field is 1.361 into 10 raised to minus 8 Tesla. So students, you may note down this numerical.